Hi class. So there's one more piece that I want to show you to help finish up this transformation section. And that's how do we manage more complicated scenes. So far we've had a single triangle or a single object that we can move or translate. So I'm going to explain hierarchical modeling as a method to help out with that. Hierarchical modeling. Modeling is in computer graphics is the problem of generating how do you describe an object like a flower, how do you describe an object like a car. That's modeling, okay? How do you represent that in your computer? So we'll learn a little bit about that here. So let's say consider drawing a flower bed. And I'm going to draw a very simple flower bed that I'm going to use throughout my examples here, okay? So here's the coordinate space. Now remember, because we're drawing a model, we started at 0, 0 in model space, so that's the space we'll be working in. Okay, so here's what my flower bed might look like. I might have a flower bed base, like a flower pot, I guess. And I have these two flowers. Each flower has a stem, each is a center, and each one's going to have 1, 2, 3, 4, 5, 6. Right, doesn't matter. 6 petals, okay? So if I'm going to draw this with the tools we've learned so far, it actually comes out to be quite tedious. So if we draw this using object space, right, with 0, 0 there, it actually becomes quite tedious. It's to plot the coordinates. Because if we're having to specify each point here, I should use a different color, each point, you've already struggled with coming up with the points. It's actually a lot of work if we had to plot the coordinates for each piece. So generally when you're doing modeling in code, you don't want to be doing that, okay? And also if we do it that way, it can be tricky to reuse code. Right? Because once I solve the coordinates for this flower here, I probably want to reuse them for that flower. And you can think, oh, I could do it with a variable and add offset and that kind of thing. But it actually gets it can be tricky to do well. It's a lot of work. For example, here we have 2 flowers that I just said. And I'm telling you now, thinking about how to solve that, with code and variables and offsets, it's ugly, it's messy, it's not the way you want to do it. I'm also going to highlight these petals. We have, all these petals here. So there's many identical petals. And at first you might not think they're the same because they're rotated, but they're just rotated. They're the same petals, right? Many identical petals, just rotated. Right? We'd like to be able to reuse that code. Okay. So the first step of making this simpler is let's break a scene into subcomponents. So we break a scene down. I'm going to call this my scene here. Break a scene or an object or a model or a thing I want to create into subcomponents, into a hierarchy. Right? That's hence the name hierarchical modeling. And once I do that, then I break it down all these small pieces into subcomponents, and then I figure out how to draw each subcomponent by itself. Okay, so we solve it individually, and I'll come back to this and you'll see why that's useful. I'm going to assume it's at 0, 0. Actually, I should probably write that differently. Assume at 0, 0. So I'm going to draw a subcomponent. I'm going to forget where it is. I'm going to draw it at 0, 0. let's say I want to draw a petal. I'm going to draw the petal at 0, 0. I want to draw a flower. I'm going to draw this flower at 0, 0. And the reason that works is if I solve it at 0, 0, to place it somewhere else, like to the left of the flower box or on the petal, I just use my transforms. I use my transforms to position them. Okay, so I solve the problem of drawing a flower at 0, 0, right? And then I use a transform to make it positioned. So let's say I'm going to draw, a flower bed. Now, the flower bed has a flower, which is a subcomponent. The flower has a stem. The flower has a center, the little circle, and it has petals. Okay? Right? So I'm going to first break this down to flower, and I'm going to make a function called draw flower. And remember, when I make draw flower, I solve that problem. Inside the flower, I draw my flower at 0, 0. Okay? So I draw a flower at 0, 0. So if I have a function that can draw a flower at 0, 0, then to use it, I just use my transformations. So this is what my function looks like. Draw flower bed. Good. First of all, I draw my rectangle. Right? Just the guy right there, up there. I draw my rectangle. You know, I can probably just draw that out for you, so we're not having to go back and forth. Here's my coordinate system. First thing I do is I draw my rectangle down here. Cool, great. And then what I do, once I draw the rectangle, then I'm going to draw a flower. But first I'm going to scale the flower. Remember, these work in skla, opposite order. So I'll write it this way. I'll translate, scale, and then draw a flower. Okay. Now, remember, reverse order, right? Because of the way the matrix works. So this will scale the flower first, bigger or smaller, then making it bigger, and then it'll move it. Okay? And that order matters, and go back to the previous lecture if that's still confusing you. So let's say I do that first for the left flower. Right? Okay, cool. And then what I do is I do another translate, another scale, and I draw the flower again. This is my right flower. Okay, so I have different translations. I change the parameters, and I can just call my function again. And now I'm going to get a flower over here. Perfect. So if I can use this hierarchical approach, I break it down. I have a flower bed, I say draw the flowers, and then I take a flower, I solve the flower problem at its own local coordinate system, and then I use my transformations to move it around. This saves me a lot of work. Okay? So this enables divide and conquer approach, where I take a big problem, like drawing the flower bed, and I break it down into a smaller problem, which simplifies my coding. Okay, and it also lets me reuse my code. Okay, so basically I solve the problem in some generic sense, and then I use transforms to modify the components. Okay, so we did this for draw flower bed, and now we can actually, let's dig a little deeper. Let's jump into draw flower. Let's do the same thing for draw flower, because it's nested, it's hierarchical, it's divide and conquer. Okay, so I'm going to draw my draw flower code and see what it might look like. So I have draw flower, Well, I'm using blue, I think, for code. Yeah, doesn't really matter, but draw a flower. Okay. And now remember, I'm drawing at 0, 0, right? Because then we can use the transforms to position it wherever we want. So I'm going to draw my coordinate system over here. And then inside draw flower, again, I just don't worry about the bed. I worry about the pieces inside. I might do a rotate, scale, and then draw the stem, which just might be just a rectangle, 2 triangles, whatever. It doesn't really matter, right? We can do it. We can draw a stem, and then, bam! I'm drawing it in my own local coordinate system. I might do something like this, and then I modify my transformation. I translate, and then I draw my center, right? So I do an offset, I come back here, I draw the center. Well, I guess this code was supposed to be in blue. It doesn't really matter. And then now I use a for loop for each petal, right? I draw my petal however I'm doing that. I can reuse this code, maybe make a function. Drat 0, 0 again, but then I do a rotate. So draw the petal, modify the matrix, add rotation, is now rotated. I draw it again, rotate again, it keeps moving. And you can just use a for loop to go around. So this is really cool. This is really nice. I guess I should finish my flower. Right? I can reuse my code, I can rely on my transforms, I can solve my local problem, drawing at the origin, and then use the transforms to position it in the object wherever I want. The same way that we draw object space in 0, 0, and then we use transforms to put it into the world coordinates. Now, within the object space, I'm using transforms to position all my pieces.